Welcome and hello. This is a video lesson in the HEC RAS controller, and we're going to call this Schematic Reach Procedures. In this lesson, we'll cover three closely related procedures in the HEC RAS controller, which all begin with the term schematic_reach. We're going to see how these three procedures work, including a quick demo in this lesson. All right, so what you see on the screen here is a simple 1D HEC-RAS model. What we have in the geometric data editor down below here is two different rivers. There's River C, which is the main river, and then over here, tributary, this is River D, which flows and combines into River C right here at a junction. Never mind the cross sections. For these rivers, what we're going to be looking at is the reaches and points, or the vertex points, that define the alignment of these three reaches. So there's River C reach 1, River C reach 2, and then over here is River D reach 1. You can't really see the vertex points too well, but if you click on Edit and then Move Point/Object, you can now kind of see the vertex points a little bit better. This is where you can actually pick the vertex point up and move it to realign the river if you need to. So you can see each of these reaches has 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8, and then let's see, further down here, 1, 2, 3, 4, 5, I believe, if I'm counting correctly, for a total of 20 vertex points and 3 reaches. So the different procedures that we're going to be looking at within the HEC RAS controller is going to provide us the number of reaches, the number of points, and then the actual XY values of each of the points as well. So the XY values are shown right down here in the bottom right corner of the geometric data editor. You can see this number 862.83, 102.44. Keep an eye on that number as I move my mouse around on the screen here. So based on those coordinates, we're going to actually have the coordinates of each of these 20 or so points that we counted that define the alignment of the reach. Why you may need this, for instance, you may want to be calculating distances, or with vertical information, you could calculate slopes. There's lots of different reasons. We're just going to demonstrate how these procedures work. Okay, so let me go ahead and uncheck my move points/objects. Those are my river reaches. And then let me go ahead and save this. All right, let's head over to the Microsoft Excel, specifically click on Developer tab and then Visual Basic. Now, if you haven't already added in the RAS reference, go up to Tools, References, and I have got the HEC River Analysis System checked on. So if you don't have that already, just scroll down to HEC River Analysis System and check it on. And then also what I'm going to do is go up to View and Object Browser, and then select my version of RAS, RAS, number, and then click on the HEC RAS controller class. After that, we'll have a list of procedures and events over here in the main window. So the three that we're going to be focusing on for this lesson are right here: schematic_reach count, schematic_reach point count, and schematic_reach points. So the first two are both functions. They don't have any arguments. They're pretty simple. They just return the long. So schematic reach count returns a long. It returns the number of reaches in the current HEC-RAS project's active geometry. And just below that, schematic_reach point counts returns the total number of reach vertex points that make up all the schematic reach lines in the active geometry. After that, the schematic reach points procedure is a subroutine. It takes in 6 separate arguments. They're all arrays, and it doesn't return anything because it's a subroutine, but it does assign values to those 6 arrays, which includes river names, reach starting index, reach point count, reach point X value, and then reach point Y value. So we're going to go ahead and see a quick demo now of these 3 separate procedures in action. So I'm going to go ahead and close this. I've got my sheet 4 is what I'm working on. So just go ahead and find yourself somewhere to write code. It's really not too important because we're just going to be printing out to the intermediate window to check what the values are. Okay, so I'm going to paste in the code that I have prepared. Boom, this is what I'm calling a subroutine called reach point data. The first part right here is standard for all these HEC-RAS controller subroutines, where I'm creating a HEC-RAS controller object right here, and then I'm opening the file. This is the project that we were just looking at, project.prj. After that, what we're going to do is get the reach count. This is the number of reaches in the active geometry by using the schematic underscore reach count. Then we're going to print out that integer to the console window. And right after that, we're going to get the reach point count, which is the number of points. So I think this number is supposed to be 3. This number is supposed to be about 20. We're using the schematic underscore reach point count function, and then going to print it out down below. Then we're going to click RAS. All right, so let's go ahead and run that. Once we confirm that this works, then we'll move on to the more involved subroutine, which is the schematic underscore reach points. All right, so I'm going to click on Save and then go up to View, click on Intermediate Window or Control G. So that opens up this window down here, which I sometimes call the console. This is where the text that you print out from a line like this that starts with debug.print will go to. So reach count equals and then our number. Okay, so I'm just going to go ahead and run this. So run subroutine. All right, so we saw RAS open and close there. Actually, I probably should have closed it beforehand, but it's closed now. But here are our results. So we have the reach count is 3, and then the reach points count is 20. Right, so far so good. I'm going to just go ahead and delete that and close the intermediate window. Okay, I'm going to go ahead and add to what we just had there. So what we had previously was this much right here, plus the quit RAS and end sub. What I just added is pretty much everything below it, starting with the 6 different arguments that we're going to be using for our schematic underscore reach points subroutine call. So that is the river names, reach names as string arrays. We have the reach start index and reach point count arrays as long, and then double arrays are reach point X and reach point Y. Now for these different arrays, they are 0 indexed when they're returned from this function. So what that means is we need to redim each of these arrays, which we just created, with the reach count -1, reach count -1, reach count -1, and then the last two is the reach point count -1 and reach point count -1. So this number right here would be 3, so -1 would be 2, and then this number right here would be 20, so -1 would be 19. It's still a count of 20, but it starts at 0, so the last index would be 19. All right, down below here is the actual call to the subroutine. So we're passing in all of our arrays of appropriate size. These are being passed by reference, which means they are assigned within the subroutine. And then what I'm doing here at the very end, before quitting and ending the sub, is I'm calling a function, a subroutine further down here called print array. This is just a quicker way to do it because I'm going to be doing the same thing 6 times. This is the name of the array just to print out as a label, and then the actual array itself, which looks like we're going to read in as a variant because remember these arrays are of different data type. We're going to print out the name of the array that we pass in for the first argument. And then after that, we're going to loop through the array and just print out the individual values. All right. So hopefully that's all straightforward, and hopefully that makes sense as far as the usage goes. Let's go ahead and see if it actually works though. So I'm going to save, and then I want to view, open up that intermediate window down below. And then let's just go ahead and click the cursor inside that subroutine and run the sub. Okay, so hold on, let me see what we got here. I'm going to scroll up. All right, very cool. This looks correct actually. So the first 2 lines, we saw that already. We're just repeating that process. The first array that we passed in and are now printing out is the river names, which is River C, and River D. Remember, this is on a per reach basis because the next array down here is the reach names. So we're dealing with River C, reach 1, River C, reach 2, and then River D, reach 1. All right, after that, we have the reach start index. Of course, it's always going to start at 0, and then 7 and 12, which means that the number of points in River C, reach 1, is from 0 up to 6 for a total of 7. And then the number of vertex points, XY points, defining River C, reach 2, starts at index 7 and then ends at 12 minus 1, 11. So that'd be a total of 5, which is right here. And then finally, in River D, reach 1, the only reach in River D it would start at an index of 12. And remember that the total count is 19. So 19 Minus 12 is 7, but plus 1, that gives us 8 right there for the number of reach points in River D, Reach 1. The actual points are listed out down below here. So if you wanted to know the actual starting reach point for River C, Reach 1, the x value would be negative 282.86658, so on. That's the x value. The y value would be right here, 880.8411214, and so on. So there should be a total of 20 different x values and 20 different y values. We could obviously print this out to the Excel spreadsheet. We could use these numbers for calculations of all sorts of things, but the purpose of this lesson was just to become familiar with these three functions we talked about: the schematic reach count to get the number of reaches, schematic reach point count to get the number of points, and then finally schematic underscore reach points subroutine to get all the juicy details associated with the points and the coordinates within the active geometry.